All right, let's dive into naming compound using the concept of valency, right? So that's the next thing. I've given you this table in last class, right? And I've explained all of this, right? So let's dive into naming compound using the concept of valency. All right, from here now, note the following. Two elements can only combine to form a compound if they have opposite charges, right? So elements with the same charges do not readily combine. So what I'm saying is that when two elements are combined together to form a compound, they must be of what? Opposite charges. One should be plus and the other should be what? The minus, so that they can attract. So note that when two atoms are combining to form a compound, they exchange their power, ignoring the sign, right? They exchange power, ignoring the sign. So look up, this is what I mean. Let's say I have an element X combining with an element Y such that X is raised to power A to power minus 1 and I'm having B plus, right? That is, they are opposite charges. This is plus. This means X is what? Gaining one electron. This means Y is what? Losing one electron. So they must be of what? Opposite charges. So if these two elements want to combine to form a compound, hence the compound becomes something of this nature. Look up, the compound becomes, pick up, we said they exchange their power. This B comes here and this A goes here. So I'll have X first. Next up, this B comes here, becomes B. Next up, I'm seeing this Y, next Y. Then this A comes here, I have A. This is how to write a compound. This is like the idea on how to write a compound. So just exchange their power and ignore the sign. So the sign here should be minus, but I ignore the sign. You are meant to ignore the sign. So right, those are the concept behind this stuff here. All right, from here, let's take a quick example and to understand this concept more better. Example one. Example, let's say I have an element number one. Let's say I have let's say hydrogen H plus combining with oxygen 2 minus, right? Let's see what this will form. Let's say the compound that this will form for us. We said our first task is to what? Exchange the power. This 2 comes here, so we'll have H first. This 2 comes here, I'll have 2. Next up, this oxygen here. This 1 is 1. When 1 come here, it becomes 1. I thought I can clean this 1. So this is what? H2O. This is water here. This is like the idea. Let's take one more example. Let's say I have sodium Na plus combining with chlorine Cl minus. Let's see what this will form, right? So we said our first task is quite simple. The power here is 1. So when 1 comes, it becomes Na, right? Then stop Cl. This is sodium chloride, right? This is how to write or perhaps how to write compound, right? Using the idea of valency and also perhaps a radical, right? So this is like the idea behind naming compound using the concept of valency, right? So when just observe that when two elements are combining to form a compound, they exchange their power, ignoring the sign. That's all. All right, it is also important to note that when two elements are combining to form a compound such that they are of opposite charges but the same power. Look up, I mean, let's say X is combining with Y such that X is equal to power A minus A plus. This can combine, right? Because what? They are opposite charges, but what? The same number. So what happened in this case? In this case here, they exchange their power normally, ignore the sign, such that at the end they cancel out. So it means that in this one here, I will have X and A, then Y, A, such that at the end they cancel out. So my compound there becomes X, Y as my compound produced, right? So just observe that if they are of the same power but different charges, they cancel out, right? At the end they cancel out. Example of this one is that if I have calcium combining with calcium, if I have calcium combining with an element there, oxygen, 2 minus, right? These are of opposite charges. So let's try to combine these two. First task is that take this calcium first. These two comes here, I have 2. Next up, oxygen. These two comes and becomes 2. They have the same stuff, so they cancel out. At the end, I'll have calcium dioxide, it's CaO, right? Calcium dioxide. So this is like the concept behind naming compound, right? So one line space paragraph. Some compounds or perhaps some elements have varying oxidation number. Example number 1, lead. Lead, that is Pb. So Pb has Pb2 plus or Pb3 plus, right? So lead, we said oxygen is it is part 2 minus, hydrogen is H plus, sodium is Na plus, right? But lead too has its own ion, so lead can be either +2 or what the +3, right? It depends, right? So that's like number 1. Number 2 there is copper. Copper, that's Cu. Copper has also varying oxidation number. So Cu perhaps. Cu plus 2 plus, Cu3 plus, right? It's like the varying oxidation for calcium there. Copper, please. Copper, right? So like the idea behind this man here. So let's say I'm giving an example. Write lead 2 triosonitrate 5. Write lead 2 triosonitrate 5. So if I want to write the compound of lead 2 and triosonitrate 5, they are combined to form a compound. So I'm having lead 2, that's Pb2 plus, lead 2. Next up, triosonitrate 5. I gave in radical here. So triosonitrate 5 is NO3 minus plus 1 minus. So I'll have triosonitrate 5, 1 minus here, right? So this can combine. Why? They are of what? Opposite charges. So when they combine, what would they form? Take out your Pb first. This one comes here. One is okay here. Next up, NO3, such that this 2 comes down here. Don't put the 2 here. This is 32. Your task is to encase this in a bracket and add your 2 here. This is like the compound here produced when lead 2 and triosonitrate combine. This is like the compound they produce here. So by now you should not write compound, right? So example 2, limestone using in making cement is got by the combination of calcium and triazocarbonate 4, right? Triazocarbonate 4, yeah. So let's now the question now says, what is the correct formula for limestone? So in that case there, I'm having calcium, that is Ca2 plus, combining with triazocarbonate 4, that's CO3, that's 2 minus, right? So what is the correct formula for limestone? Let's get the correct formula for limestone. The correct compound of that formula for limestone becomes, observe that this one here and this case are the same thing. They have the same bit number but different charges. We said at the end it will cancel out. So it means that from here I'll have that Ca, this one, then this 2 comes here, I have 2. Next up, CO3, this 2 comes here, I have 2 here, such that they cancel out at the end. My final compound or formula becomes CaCO3, calcium triocarbonate, right? So this is like the formula for limestone, right? So you can try checking out past questions on these stuffs, right? So try to know how to write compound, or perhaps how to name compound using the concept of valency, right? So this is how it works.